Now we're going to focus on the third terrestrial planet from the Sun, and that is our Earth. Now you should know that Venus and Mars are on either side of Earth. Venus considered the sister of Earth, while Mars is considered the little brother. Now Earth has one natural satellite, which is the Moon, and we do know that the Earth is covered primarily with water and has a dense atmosphere of nitrogen, oxygen, and hydrogen. And from what we are aware of, Earth is the only planet that's able to support life. Now, majority of what we're going to kind of skim through, we have actually spent this whole year covering. So 3/4 of this year, we've focused on the Earth. We have been focusing on the Earth. So I'm going to skim through a lot of these slides. You can go back if you want to and take a look at those, but you are responsible for this content. It is in your Fitbin, but I'm going to go through this, not really giving a major explanation because you should already know the content on Earth. When we move to the Moon and Mars, I will spend more time explaining or talking and reading through the content. So you should know that we have the crust, mantle, and core. We can divide this up into upper and lower mantle and inner and outer core as well. So we have seen this structure. So you can go ahead and pause this as we've already looked at this and talked about the structure of the Earth. Now we spent a long time talking about plate tectonics, the boundaries and the movements. We've talked about what a plate is, the broken pieces of the lithosphere. As we go through and we just review this content, be aware of the terms of tectonics. What is plate tectonics referred to? What is a plate? How these plates come together or move apart. We talked about convection, the rising and cooling, heating and then rising, and then the cooling and sinking of the magma in the mantle. This is the slide that we really spent a lot of time with when we talked about earthquakes, about if we have convergence coming together, divergence moving away, or if it's sliding past each other, that's going to be your transform. So this is a review of your types of plate boundaries. If we have a divergent boundary, magma is going to come up as it's separating. Then that leads us into not just boundaries, but faults. Now remember, faults will happen at a plate boundary, but they can also happen at different places outside of a plate boundary. Makes you know what is a normal fault. Makes you know what a normal fault is, as specifically if it's coming down the slide, that's normal. When we have convergent coming together, remember there are 3 types: continent to continent, creating mountains; continent to ocean collision, which would be your subduction; and then ocean to ocean, which would be your trenches and underwater mountains. Okay, make sure you know some examples. And then, of course, when we have converging coming together, it will create not just a convergent boundary, but you can have a reverse fault. Think about its opposite going up the slide. And this, again, can happen not just at a boundary. And then we have the transform. This is sliding past each other, not moving away, not coming together, but sliding past. And that would yield our strike-slip fault. We have the specific rim, which details the outline of plate boundaries. Not just subduction, but you'll have rifting, the ripping away, allowing for magma to come up, as well as, like Hawaii, a hot spot. Now let's move to the Moon. Now in the 1950s to 60s, a lot of probes were sent out to the Moon. You should be aware of already Neil Armstrong being the first man on the Moon, and that happened July 20th, 1969. Since then, 1969 to 1972, so in a matter of 3 years, we had 6 Apollo missions. If you ever heard of Tom Hanks' movie based on Apollo 13, during those missions, there was a lot of collection of rocks from the Moon. A total of 12 different Americans, not just Neil Armstrong, have walked on the Moon. Basically, you will need to know some of the lunar features. Lunar, remember, means moon. You're going to need to know the craters, which are the meteorite impacts, the small little dents, while the term Maria, which means oceans. This is what we see from our house, those little patterns on the moon are called marias, which means ocean or sea. But these are not really oceans. These are actually basaltic plains, very flat areas. Now there's four main shapes of the moon, and we're going to use these: the full moon, crescent moon, quarter moon, and gibbous. Basically, we're going to use that for our knowledge of the phases of the moon. So when we focus on the new moon, and this is something that you will have to draw and will need to know, you'll see this on your quiz. When we see a new moon, we're not going to really see it. It's going to be kind of hidden or in an eclipse. But then when we move to the waxing crescent, this is like the fingernail clipping. This is like the toenail clipping. It's very small. Think of a crescent roll. It's in that shape. Now, waxing means starting, coming in. So think about if you're waxing the car, you're going to start waxing the car. When we move to first quarter, that's going to be technically, it looks like it's the half of the moon, right? But this is only 1/4. Don't forget. So this is only 1/4 that's visible. And then we're going to move to the waxing gibbous. The gibbous is primarily about maybe 80-90% of the moon is visible for us. It's getting bigger. It's moving towards the full moon. And then when the full moon starts getting smaller, we're going to use that word when it's decreasing in size, waning. The waning gibbous, here we again have the biconvex shape of the moon. Its majority of the moon is visible, but it's going to be on the other side. Okay, as you can look at waxing gibbous, majority of what we see is on that right side, while the waning is starting to disappear, and that's going to be on the left side. Then we move to the last quarter, then the waning crescent. Okay, this actually shows how we see some parts visible while we see other parts kind of hidden, and that's because of the shadows. And it will be showing you the shadows and what we're able to see. So the light parts are what we're able to see, while darker gray will be the shadow, and that's the part that's actually hidden from us. Now let's move into Mars. Mars is the fourth terrestrial planet. Remember, terrestrial meaning land planet. And it's commonly referred to as the red planet, mainly because of the iron oxide. Remember iron oxide, which is commonly known as rust. Now, Mars was also the Roman god of war. Now, Mars is very rocky. If you watch any of the footage of Curiosity on Mars, very rocky, very dry. Now, as we said, Mars is considered Earth's little brother, but it is similar, but it's smaller than Earth, and that's why it's little brother. Now, Mars will spin just like Earth does in that rotation. Now, one day on Mars is 24 hours and 37 minutes, so it's slightly longer. So that means the spin is going to be a little bit slower, just slightly slower than what the Earth is. And like Earth, Mars does have a seasonal tilt. It has an axis. And just like Earth, it will have seasons. Earth and Mars both have polar ice caps, but Mars does not have liquid water. It's just frozen. So there's no liquid water on Mars. Just at the polar ice caps, it's just frozen. So the question is, why just at the poles is there water? Where did the water come from? Was it naturally there? How come there's no other water there? It's very interesting. There's not a lot of explanation there. Now, Mars is very cold compared to Earth. So you have to think about Earth is at the right distance for life to the sun. Remember, Venus and Mercury are too close for life. Mars, too far away. So it will be too cold. And then we were talking about the Martian day is close to the Earth, but the Martian year, the orbit around the sun, is actually slower than the Earth. It is further out, but it's actually close to being double in Earth year. Okay, so about 2 Earth years. And Mars's atmosphere is much thinner than Earth's atmosphere, and instead of nitrogen, hydrogen, and oxygen, it's going to be mainly carbon dioxide and nitrogen. And we asked that question, where's all the water on Mars? Why is the water just at the poles? Did it get there from somewhere else, or did Mars have water? Now, what's interesting is Mars, remember, there's no lakes, no rivers, no oceans. But looking at the surface of the of Mars, it actually looks like there could have been water there because a lot of the rocks are broken down as sedimentary rocks. Could that have been caused by water? But we do remember sedimentary rock, these sediments not only can be created by water, but it can be created by wind. Now, one of the largest volcanoes on Mars, from what we're aware of, is Olympus Mons. This is an extinct volcano, being about 14 miles high. So it's the highest mountain in the solar system. It's about the size of Nevada. Here's the Mariner 4, which flew by Mars. So we focus on the Mariner 10 with Mercury, but here's the Mariner 4 in 1965. We had the first flyby. These are the pictures, and you can see the little meteorite impact craters. Then in 1997, on Mars, we have the first little rover. This is the SOJOURNER. Then in 2012, we have the Curiosity. You can see the size difference between the SOJOURNER and the Curiosity, which is the larger one. Now, the Curiosity was radioactively powered and had solar panels. And here's the latest one. This is the Perseverance. This rover launched in 2020. And basically, it took about 7 months for the satellite to get from Earth to Mars. And then it landed on the surface of Mars in 2021. So it left Earth July 30th, 2020, and it landed on Mars February 18th, 2021.